Hi there, my name is Dimitris Charalambidis, and in this video we will see one type of exercise which is based on the tree diagram. In this type, it's the type in where we will be given a tree diagram and we will be asked to find the probability of a specific outcome. The methodology in this case goes as follows. We need to recognize, to find all roads leading to this outcome, calculate their probabilities separately, and then add these probabilities. So we need three things. Once again, recognize all roads leading to this outcome, calculate their probabilities separately, and add them. Let's see that through an example. You are given this tree diagram. It says it's about the selection of bus or car in order for us to go at school. There is a probability of 0.7 to go by bus and of 0.3 to go by car. And then, based on our selection, we have the events of being late or on time. And you can see the corresponding probabilities on each one of these branches. Now, in a previous video, because remember that this video we are now doing and you are now watching is the third video in the sequence of tree diagrams. So far, in the first video, we have seen what a tree diagram is. In the second video, we have seen how to calculate the probability of a specific road. We already know how to calculate the probability of using bus and being late. And now we want to see how we can actually calculate the probability of being late. Here, a common and a question that we would expect from a student would be the following. Being late by what? Late by bus or by car? And that student would be absolutely right. No one ever cared. So we need to consider all these cases. That's why I said before that the first thing that you should do is recognize all the roads that can take us to that. So one road would be the probability of using the bus and being late, or the car and being late. So we did step one. We did recognize each road leading to lateness. Now we need to calculate separately the probability of each road. The probability of bus and late is equal to 0.7 times 0.1. This is bus and late. And the probability of car and late is 0.3 times 0.3 respectively. Car and late. Just let me write that properly. That's step number two. And now we need to add them. So overall, the probability of being late would be 0.7 times 0.1 plus 0.3 times 0.3. That would have been 0.07 plus 0.09, which is equal to 0.16. Similarly, the probability of being on time, once again, since we care about a specific outcome and not a specific event, not a specific road, sorry, we need to recognize all roads leading to this outcome. We need to end up on time. This can happen by using the bus and being on time, or by using the car and being on time. I managed to recognize them. Now I have to calculate their probabilities separately. Bus and on time is the product of the probabilities found on each one of these roads, 0.7 times 0.9. Car and late is also the product of these probabilities, 0.3 times 0.7. I calculated them separately, and now all that is left is for me to add them. 0.63 plus 0.21, which is 0.84. and that was the probability of being on time. Once again, to summarize, if we are given a tree diagram and we are asked to find the probability of a specific outcome, then there are three things that we need to do. First, recognize all roads, all the sequence of paths, all the sequence of branches that lead to this outcome. Then, for each one of them, calculate the probability separately, and finally, add all these probabilities together. And that would be all. For any questions, as always, that you might have regarding what you just viewed, you are always free and welcome to leave your comment below. Thank you for your time.